Hello, Math 130 students. We are going to pick up on page 12, section 6.6, dividing radical expressions and rationalizing the denominators. So to rationalize the denominator, we multiply both the numerator and the denominator of the fraction by a radical that will produce a radicand in the denominator that is a perfect power for that index. For example, let's look at 38. First of all, I want to see if 38, how it breaks down into its factors. So I know it's an even number, so 38 divided by 2 is 19. So 2 and 19, those are both prime numbers. I can't factor any further. So this tells me that I want to multiply top and bottom by the square root of 38. Okay. So the reason I do that is because now I'm going to have 2 square root 38, and down at the bottom I'm going to have a 38 squared. And don't forget that your index is 2 as well. Well, now that your index and your exponent can cancel, you would be left with a 2 square root 38 over 38. And this is rationalized or simplified because the radical is no longer in the denominator. So that's going to be your goal. So your goal is to get rid of radical in denominator. That's what you're going to be trying to do for each one of these problems. So let's look at number 2. So for this one, I have now the index of 3. So I want to be a bit more careful. And I'm looking at the number 169. Because that is what I have. So let's see if 169 can be factored. So I just found that 169 can be divided by 13. So I'm going to say that 169 is equal to a 13 squared. So I'm going to use that information. So I have a 5 over the third root. And remember, this is a 13 squared times your W. So now you want to multiply top and bottom to get rid of that 13 squared. So the only way to do that is if you multiply top and bottom by the exact same thing. And since I had a third root or an index of 3, then I know I need to have an index of 3. So you are trying to get it so that when you multiply everything together, you have a power or an exponent of 3. So in order to do that, if I have 13 squared and I want to get to 13 to the third power, well, how many more 13s do I need to multiply by? Well, I need to multiply by one more, so a 13 to the 1. Now look at our W's. If I have W to the 1, and your goal is to get to W to the third, then what would you multiply it to get to that 3? Well, that would be W squared. So you would multiply top and bottom by 13W squared. Well, let's see what happens when you do that. I have a 5. I have a third root of a 13W squared. And down at the bottom, I still have my third root. I still have my 13 squared times W. That's what I started off with. And then I multiplied by my 13W squared. Well, the reason I did that, well, you know that your numerator stays the same, so that's fine. But now, down at the bottom, for that third index, I have a 13 to the third power, and I have a W to the third power. So I know that those are going to cancel out. So my numerator still is the same. And now, since I have my power and my index that are going to divide, I have a 13 that jumps out. Same thing with my w. The index divides my exponent. So 3 divided by 3 gives me 1. So I really end up with this 5 third root of 13w squared being divided by 13w as my final answer. So let's take a look at number 3 now, okay? So if I'm looking at this, I want to see what I can do. Well, I know from my rules of quotients, my quotient property is that I can split this up. So I can rewrite this as the third index, or the third root, of my numerator, which is 13 up on top, and then my bottom, 875. Okay. Now, what I want to do is I want to break down 875 and see what I find. So I'm going to go ahead and do that. So I went ahead and did my factor tree for 875. So the really cool thing about this is that 875 factored as 5 to the third and 7 to the 1 power. So I'm going to go ahead and reduce that. So I still have my third root of 13. And down at the bottom, I have my 5 to the third root times 7 to the first root, to the first power. So that means this 5 gets to jump out. So in my numerator, I have 3 to the 13. And now I have 5. And now I'm dealing with that 7. So this makes it a bit more manageable. So now I know that I'm going to multiply top and bottom by a third root. And since I already have 7 to the first power, well, if I have 1 7, I need 2 more to get to 7 to the third power. So 7 squared is what I'm going to be multiplying by. So now, in my numerator, I have my 3 times that 7 squared. And down at the bottom, I have 5. And I have that 7 times that 7 squared. So 7 times that 7 squared really just gives me 7 to the third power. Well, what happens when I have 7 to the third power, since I combine this 7 and those 7s, is that now, since I have my index of 3, it gets to jump out. So in my numerator, I'm just going to multiply. I have 3 times 7 squared, so that's going to be 147. And down at the bottom, I have 5 times 7. So I have my third root of 147, and 5 times 7, which is 35. And that ends up becoming my final answer. Now let's take a look at number 4. Well, I can see that my denominator here for number 4, I have an index of 4, so I'm going to have to simplify that a little bit more. So let's look at the numbers that we have. So it looks like we have the number 36, so we can go ahead and split that out as 6 times 6. Well, that can be split up as 2 times 3. So I have that 36 is equal to 2 squared times 3 squared. So I'm going to rewrite this. This is equal to 2 fourth root, and I have my 2 squared times my 3 squared, and I have my m squared as well. So that's going to help me to decide what I'm going to multiply top and bottom by, and definitely has to match my index, which is a 4. So if I have 2 squared, but I want it to match my index, then I need 2 more. So 2 squared times 3 squared times m squared. And so when I do that, up in my numerator, I have 2 times the fourth root of 2 squared times 3 squared times my m squared. And down at the bottom, remember, I have my fourth. I have 2 squared multiplied by that 2 squared. I have my 3 squared times my 3 squared. And I have my m squared times my m squared. And the whole reason I did this was so that I can cancel out some terms. So up in my numerator, I have my 4 times 9 times my m squared. Down at the bottom, I now have 2 to the fourth, 3 to the fourth, and m to the fourth. So I can simplify that. In my numerator, I still have the fourth index. 4 times 9 is my 36m squared. And down at the bottom, my 2 gets to jump out, and the 3 gets to jump out as well. So 2 times 3 gives me a 6, and the m gets to jump out, so that's going to be an m. So, and I went too fast. If there's anything that can reduce, always reduce if possible. Well, 2 goes into 6 3 times. So really, I'm going to have my final answer simplified as possible. So I have my fourth root of 36m squared, and on the bottom, 3m. And that will be my final answer. Remember, your goal is you do not like the radicals in the denominator. It's okay to have them in the numerator, that's fine, but just not in the denominator. So no radicals, no square roots, no fourth roots or third roots. Any type of roots cannot be in the denominator. So now for number 5, we're switching gears a little bit. Now what's going on is we are dividing by a binomial with a radical. So what we have to multiply now, top and bottom, is going to be the conjugate. So the conjugate is, let's say for example, if I have a plus b, then the conjugate would be a minus b. So what happens is just that the sign in the middle changes. That's the only thing that changes, is just the sign. Everything else stays the same. So my conjugate here, I would have my 3, and since my sign is changing, minus the square root of 19. So 3 minus the square root of 19. So I am multiplying top and bottom by 3 minus the square root of 19. So what does that give me? Well, 2 times 3 is 6. 2 times a negative 1 is a negative 2. And I still have that square root of 19. Now, the reason we multiply by the conjugate is because when we FOIL, first, outer, inner, last, the outer and the inner cancel out. So you only have to deal with the first and the last. So here, my first would be 3 times 3, which is 9. If I'm dealing with my last, that would be a negative square root 19 times 19. So really, that square root and that square cancels. So I'm going to be left with 6 minus 2 square root 19 over 9 minus 19. And 9 minus 19 gives me a negative 10. So 6 minus 2 square root 19 over a negative 10. And well, here you're going to have to split it up. This is really telling you that you have two fractions. Your two fractions is 6 over negative 10 minus 2 square root 19 over negative 10. So I can see that 6 and 10 can be divided by 2. So that gives you a 3, and I have a negative 5. So I have a 3 over a negative 5. And here I have a negative times a negative, so that turns into a positive. And then I have 2 and 10, which gives me a 5 in my denominator. So up on top, I have the square root of 19. And so that ends up becoming my final answer. So here you always want to make sure that you are multiplying by the conjugate if need be. Now let's look at number 6. Here I need to multiply by the conjugate. So that would be 9 plus the square root of z. So 9 plus the square root of z gets multiplied both in the denominator and my numerator. For this, what I'm going to do to help myself out is I'm going to work over to the side and I'm going to do a box method because that just helps me. So if I have 9 plus the square root of z, using my box method, and I have a 9 square root of z. So let's see what that ends up giving me. Well, 9 times 9 is 81. Here I have 9 square root z. Same thing in this square. And here I have a square root z times a square root z, which becomes a square root z squared, which is just a z. Okay? So now I know exactly what's going to go in my numerator. Well, in my numerator, I have an 81. I also have 9z plus 9z, and I get to add those together. So that is going to give me plus an 18 square root z. And I also have a z. Okay. Down at the bottom, I'm going to do my first, outer, inner, last. So this is where I FOIL, but remember, when I FOIL two conjugates together, the outer and the inner cancel. So I'm just left with my first, so that's going to give me 81, and my last, so it's a negative, and I have square root z times square root z, which we already know is z. So my answer, 81 plus 18 square root z plus z over 81 minus z. And that is going to be my final answer. I cannot cancel the 81 in the numerator with the 81 in the denominator because that 81 is being subtracted by z, so I can't do anything much with that. Okay, and I guess that is the end of section 6.6. If you guys have any questions, please feel free to email me, the Math Success Center, or our tutor. Thank you.